Greetings and welcome to the homework solutions video for Chapter 7, Lesson 4, Day 3, Expanding and Factoring Algebraic Expressions. Since this is a combination of so many different things, just look at the independent practice found on this page here if you need more practice. So all of the ideas in this video have been covered in other strategy videos that are posted. So if you need more explanation on any of these steps, I would definitely go check those out. So when we expand and simplify each expression for 1 through 4, what that means is we need to distribute first, and then once we distribute, then we need to combine like terms. And the reason why we need to do it in that order is that according to our order of operations pyramid, we have parentheses, exponents, multiplication, and division. And so this is where we find the distribution, and then in the addition and subtraction, this is where we combine like terms. So that is why we're going to do it in that order, and it's really important because mathematically that's the only thing that makes sense here. When we look at question number 1, this is telling us that we have 7 groups of 5 plus 4r. And then we're adding that to 9 groups of 2 minus r. So before we could combine those terms, we have to figure out what is the value of 7 groups of this, and then what is the value of 9 groups of that. So I'm going to be working with multiple colors here and showing the work in the way that I would expect you to record it on your homework. So this way of recording your work will keep you accurate. It connects nicely as your expressions become more complex, and it will set you up for more productive and more successful future mathematical years. So do it. This is the way. New episodes of Mandalorian dropped yesterday, so this is the way. When we distribute that 7 across the terms in the parentheses, I'm going to rewrite it 7 times 5 plus 7 times 4r, and then we are adding to that 9 times 2 minus 9 times r. Now I can do my simplifying. And again, order of operations is still telling us here we have combinations of multiplication, addition, and subtraction. But according to order of operations, we need to do all of the multiplications first, and then we will get to those other operations. So let's do some simplifying here. 7 times 5 is 35. Plus 7 times 4r is 28r, plus we have 9 times 2, which is 18, and we're subtracting 9 times r, which is 9r. So now that we've got those distributions done, it is now time to combine like terms. So I'm going to color code by highlighting my like terms. So 35 is a constant, and 18 is a constant. I'm being very careful to include the operations with these terms as I highlight them. And then we have our 28r minus 9r. So when I write this out, I am going to be keeping the order so that way we have the addition first and then the subtraction. So 35 plus 18, and then here I would rather do 28 minus 9, so I'm going to list this as 28r minus 9r. And remember, we can do that as long as we keep the operation with the term that it comes with. So, because remember, if you find $28 and then you spend $9, you still have a change of $17 dollars. Or if you spend 9 and then find 28, you're still going to end up with those $17 dollars. So we know we can rearrange those, and it makes the math a little bit easier for us to calculate. So 35 plus 18 is going to be 45 plus 8, which is 53. So we have 53 plus 17r for that first problem. Actually, I did some miscalculations there. 18 minus 9 is actually going to be 19. Sorry. Apologies. So that's 15 plus 19r. So notice, because I had that work written out there, and because I took the time to reorganize my terms, it was really easy for me to catch that mistake that I made as I was looking back at my work. So this is the type of work that I want you to do. It takes an extra couple of seconds to write it out, but it keeps you accurate and allows you to identify when you've made mistakes. Question number 2. It looks like we have some terms that need to be distributed, and then we have some extra terms that are over here that we can combine after we distribute. So order of operations tells us we need to do this multiplication first. So let's write it out. We have 3 times 8s minus 3 groups of 5, and then we will be adding 4s minus 2. So 3 times 8s is 24s minus 15 plus 4s minus 2. Now this becomes a combining like terms problem, so I'm going to highlight my like terms. We have 24s, and then we are adding 4 more s to that. Then we're taking away 15, and then taking away 2 more. So when I write this out, I'm going to reorganize 24s plus 4s minus 15 minus 2. 24s plus 4s is 28s. And then if we subtract 15 and then subtract 2 more, we have subtracted a total of 17. So there is our answer, 28s minus 17. Number 3 looks similar to number 2 in that we have to do some multiplication first, and then we can combine like terms. So 4 times 6k plus 4 times 7 plus 9 minus 14k. Now we do our multiplication. 4 times 6 is 24k plus 28 plus 9 minus 14k. My brain is going to want to combine these terms but while I rewrite them, but I want to not do that because I would like to make sure I stay accurate. Fight the urge in your brain to do that. So we have 24k minus 14k plus 28 plus 9. 24k minus 14k is 10k, and 28 plus 9 is 37. So our answer is 10k plus 37. Question number 4. Ooh, it looks like we have multiplication here and multiplication there, so we have to do a double distribution before we can combine like terms. So we have 5 times 2p plus 5 times 5 plus 4 times 2p minus 4 times 3. So we're left with a multiplication, addition, and subtraction. So let's do our multiplication first. 5 times 2p is 10p. 5 times 5 is 25. 4 times 2p is 8p. And then 4 times 3 is 12. I'm going to highlight my like terms. I'm going to make sure I include the operations with those terms, and then reorganize. 10p plus 8p. Again, fighting the urge. Like, yes, you could probably do that math in your head, but let's get in the habit of rewriting all of it and then solving it so we can more easily catch our mistakes. 18p, and then 25 minus 12 is 13. So we have 18p plus 13. All right. Number 5 and number 6 says simplify each expression. So that could either mean distribute or it could mean combine like terms and then factor it. So we're going to be doing some distribution, combining like terms, and then factoring, making sure that we show each step of your solution, obviously. So question number 5, it looks like we don't have to worry about distributing, but we do need to combine some like terms. So we have 14x, we have a minus 8x, then we have a minus 1, and a plus 13. So when I rewrite these, I am going to make sure I do the addition first. So, the 14x, we're subtracting 8x, that's fine. Now here's where I'm going to flip-flop the order. I'm going to add my 13 before I subtract, because I know it's the same. I get the same answer if I subtracted and then added. We've been through this lots of times. 14 minus 8 is 6x, and then 13 minus 1 is 12. So we've combined like terms. Now we're left with this, and we need to factor it. So when we're factoring this, I'm trying to think, what can both of these numbers be divided by? Or what is the greatest common factor of 6 and 12? And I know the greatest common factor of 6 and 12 is 6. So this 6x, I'm going to pull out that common factor, and I know that is a 6 times x plus, and that 12 is a 6 times 2. Now because this 6 shows up before both of those terms, that means that was the number distributed to an x plus 2, or the whatever pieces are remaining. So my answer for when I've combined like terms and then factored is 6 times, in parentheses, x plus 2. All right, for number 6, before we can combine like terms, order of operations tells us we have to do this multiplication first, and then we'll be able to combine. So let's do 8 times y plus 8 times 3, and then plus 6 minus 3y. So 8 times y is 8y plus 24 plus 6 minus 3y. I'm going to do my highlighting of my like terms, being very careful to bring those operations with me. And then let's rewrite. 8y minus 3y plus 24 plus 6. 8y minus 3y is 5y. 24 plus 6 is 30. So again, our greatest common factor is 5. So I know this 5y is really a 5 times y, and that 30 is a 5 times 6. That 5 shows up before both of them, so I know that is my term in front of the parentheses. And then I am left with a y plus 6. So that means this 5 must have been distributed to a y plus 6. Number 7, looks like we have some terms out front and then some distribution that needs to happen. So even though this distribution is happening here, because it is multiplication, we need to do that first. So I'm going to do 9 times 3, and that is subtracting 9 groups of v. 9 times 3 is 27. Minus 9v. I'm going to bring the rest of this down. And now I'm going to highlight so I can combine like terms. 14v, we're subtracting 9v, we're subtracting 12, and we're adding 27. So I'm going to rewrite this so that way we are putting our terms in order. And with these numbers here, I'm going to do my plus 27 and then subtract the 12, because that is easier calculations for me. 14v minus 9v is 5v, and 27 minus 12 is 15. So again, our greatest common factor, so we can factor this, is going to be 5. So I'm pulling out a 5 from here, so that's a 5 times v, and 5 times 3 equals 15. This 5 showed up in both. That must have been the term that was distributed, the number that was distributed. So we have a v plus 3 left over. There's your answer. And finally, number 8, we have 2 distributions that need to happen before we can combine like terms. So we have 4 times 2w plus 5 plus, ooh, do you see what happened? I didn't write this out, and then I forgot to include that in there. 4 times 5 plus 4 times 3w minus 4 times 2. Let's do our multiplication here. 8w plus 20 plus 12w minus 8. Color code my like terms, making sure to take the operations with them. Rewrite and reorganize. Simplify by combining like terms. And now I need to figure out what is my greatest common factor of 20 and 12. So for this one, you know, I'm going to do this with the ladder, the double ladder method, or really now it's like the expression ladder. So I know I can take a 2 out of both of them, and I'm left with 10w plus 6. And I can take another 2 out of both of them, and I'm left with 5w plus 3. 5 and 3 are both prime, so there are no more factors of that. And so our greatest common factor is 2 times 2, or 4. So that means that we must have done 4 times everything that was left. 5w plus 3. And I'm just going to rewrite this over here. A 20w plus 12. If I know my greatest common factor was 4, this 20w becomes a 4 times 5w, and this 12 is a 4 times 3. The 4 showed up before both of them, so that must have been the number that was distributed, and we are left with that. So either way you look at it, this is your final answer, I think.